The language of mathematics makes it easy to express the kinds of thoughts that mathematicians like to express. This is aided by characters, expressions, and sentences of mathematical language. In this video, we're going to explore the building blocks of mathematical language and learn to distinguish between expressions and sentences in real-life scenario. Okay team, we need a precise retirement plan for our client. Mathematics is precise. It can clearly be stated, yielding only one answer to a given question. It should also be concise.
Yes, that's right. It should be concise. Mathematical language should be concise because it can be briefly stated.
So, what are the key factors?
Life expectancy, inflation, and investment returns are crucial. We can use models, which can utilize formal structure. In mathematical language, formal structures provide a framework for analyzing and modeling artificial and natural languages.
Exactly. Models with a specialized vocabulary,
a unique set of terms and symbols.
It allows us to assess risks effectively.
We can use models in their symbolic recitation for more comprehensive analysis. Mathematics uses symbols, numbers, and diagrams to express, define, and prove concepts, much like words in spoken and written languages.
Therefore, while comprehensive will be presented concisely.
Mathematical languages is powerful because it can express complex ideas into simpler forms.
Investment strategies must be aligned with the customer's risk of tolerance and time horizon. We can use a precise portfolio allocation models.
Tax implication will significantly impact the plan. We need to factor tax rates and potential deductions.
The client's desired lifestyle in retirement must be considered. We need precise estimates of living expenses.
Okay, based on the data, the project for the client will need $3 million for retirement.
Our risk assessment shows that 90% of probability can achieve this goal. Diversified portfolio with a mix of stocks and bonds is recommended. Advantage accounts will help minimize staff liabilities. This plan allows for comfortable living expenses and travel.
I have baking powder and all-purpose flour, but I don't know if I've got over budget. Can you help me with the math?
Of course, math is part of our shopping editing. Let's break it down and figure out your budget. We'll start with the basic expression first, and then we'll make a full statement about your budget.
Alright, I'm ready.
Great, so let's look at the baking powder. You bought 3 baking powder, and each baking powder costs $1.50. To figure out the total cost of baking powder, we use a mathematical expression, and here's the expression. To simplify means to multiply the price of the baking powder by the number of baking powder you bought.
Okay, so that would be $4.50 for the baking powder, right?
Exactly. Now let's move on to all-purpose flour. You bought 5 all-purpose flour, and each all-purpose flour costs $2. The expression for the cost of all-purpose flour is, so what do you get if you multiply?
5 times 2 is $10. So the cost of all-purpose flour is $10.
Perfect. Now to find the total cost of both the baking powder and all-purpose flour, we add the two expressions together. The total cost is, so let's add up together.
Okay, $4.50 for the baking powder and $10 for the all-purpose flour. That gives a total of $14.50. Got it?
This is an expression that represents the total cost. But again, it isn't full statement until we evaluate it. The expression represents the part of calculation but don't make a complete statement. They can be simplified or evaluated, but they don't say something directly about the relationship between quantities.
Sentences state a complete thought that can be true or false. It uses symbols like equals, less than, or greater than to form a complete thought. Let's apply it here in the grocery store. Let's say you're planning your weekly grocery shopping. You have a budget of 1,000 pesos. You have to buy an item cost 550 pesos, 150 pesos, and 200 pesos. So in a mathematical sentence, it is written like this. 550 plus 150 plus 200 is less than or equal to 1,000. This sentence uses the plus symbol to represent the addition of the cost of your grocery items. This less than or equal to symbol expresses the condition that the total cost must be within your budget. The complete thought is that the sum of the cost of the items must be less than or equal to 1,000. So this mathematical sentence can be evaluated to be true.
In conclusion, the language in mathematics is different from natural language. Mathematical language is characterized by its precision, conciseness, power, use of symbol, specific vocabulary, and formal structure. It enables the clear communication of complex ideas through a unique system of symbols and specific vocabulary. Meanwhile, expression and sentence is a complete different idea. Expressions are mathematical phrases that incorporate numbers and operations, while sentences are statements that states a complete thought and is comparable to English sentence. In summary, the structured nature of mathematical language allows for effective and efficient expression of ideas, facilitating understanding and problem solving in the field, which also serves as a clear and universal way to communicate logic and reasoning.